Hello, we're going to do a few homework problems. So we're going to start with this one where f of x1, x2, x3 equals 144, x1, x2, 1 minus x3, and that is over the range of 0 is less than or equal to all x1, x2, x3, less than or equal to 1. That's also where x1 plus x2 plus x3 has to be less than or equal to 1, and it's 0 otherwise. Okay? And the question we have is the probability that x1 plus x3 is less than or equal to 0.5. Now the way we're going to set that up is we're going to set that up with a triple integral over the function, the density function here, 144, x1, x2, 1 minus x3. And because I'm looking to see what the probability of x1 and x3 are, right, the first thing that I'm going to integrate out is going to be the dx2 that I don't need, and that will be 1 minus x1 minus x3. So what I'm doing there is I'm basically saying, if I just assume that the limit of integration, the constraining one here is going to be x1 plus x2 plus x3. So basically that's telling me that x2 has to be 1 minus x1 minus x3, right? And this will say that the probability that x2 happen, any value of x2 that it could possibly be, right, is right here. So this is basically going to integrate out that density, and it'll give me the marginal density for x1 and x3. And so then what I'm asking is, I ultimately want to know what's the probability that's going to be 0 to 0.5, because that's what I'm integrating to. And so then I need to say, well, if it's 0.5, then that's going to be 0.5 minus whatever the value was for x1. And so then basically that allows me to say dx3 here, because what's going to happen is when I evaluate x3, right, it's going to put in a value for x1 there, and then I have dx1. Okay, so we're going to turn to an integral calculator online to finish this problem. All right, we're going to go to, I'm going to put in Wolfram Integral Calculator. And I'm going to go to the integral calculator right here. And I'm going to highlight this, and I'm going to enter in a definite triple integral. And then we're just going to enter that problem that we had. So we're going from 0 to 0.5. Now instead of doing x1, x2, x3, it gets a little confusing. I'm just going to turn it to x, y, z instead. So we're going to say from 0, instead of going to 0.5 minus x1, I'm just going to say minus x. And from 0 to here, we're going to go 1 minus x minus z for x3. And then my function in here is going to be 144 times x times y times 1 minus z. And then we're going to do dy because we're integrating out over there. And then we have z and then finally x, right? So that's just the problem that we had set up. So we run over here to compute. And we get a value of the probability is 0.53125 to 5 decimal places. So for our next problem, we are saying that there is a plane that is flying at a rate of speed that is normally distributed with 500 kilometers an hour, standard deviation of 10. And in a parallel track, there is another plane that has normal distribution 520, 520, standard deviation of 10, okay? And there is a difference beginning here of 10 kilometers between the two planes. And our question is, what is the probability that after 2 hours, so let's call this y and this x. So the probability that y minus x plus the 10 kilometers between them is going to be less than or equal to 10 kilometers at the end of the day. Okay, so what I'm going to do is, you can work this out just like this, but well, I'll work it out for now this way. So what I'm going to look at is the distance is going to be defined as 2 hours at the rate of speed of y minus 2 hours at the rate of speed of x plus the 10 kilometers that they had different to begin with, and that is going to be the difference. So what I know is that both of these are normal random variables. So if we have some addition or subtraction, same thing, of two normal random variables, then that distance is also going to be normally distributed. So what I have to do is I have to estimate what is the mean of that normal distribution and what is the standard deviation. So for me to get the expected value of the distance, right, that's the expected value of 2y minus 2x plus 10, right, is going to be equal to the expected value of 2y minus the expected value of 2x plus the expected value of 10. And so if I look at that, I can bring the 2 out of the thing. So I get 2 times the expected value of y minus 2 times the expected value of x plus the expected value of 10. And what I will get is the expected value of y we know is 520. So that's going to give me 2 times 520 minus 2 times 500, which is the expected value of x, plus 10. And that's going to give me a value of 50 kilometers, right? So that's my expected value. We're now going to look at the variance, right? So if I were to look at the variance of this distance, 2y minus 2x plus 10, well, that's going to be equal to, when we bring the 2 out, it will end up being 4 times the variance of y plus 4 times the variance of x. And then the variance of a constant is just 0, right? So it doesn't vary at all, right? So that becomes my variance. Well, I know what these are, right? So what I'm going to do is I'm going to convert it at this point, just to make the math easier, to the square root so that I get the standard deviation. So the standard deviation here now that I'm looking for of the distance is going to be equal to 2 times the standard deviation of this, which is 10, plus 2 times the standard deviation of this one, which is also 10. So that's going to give me 40 kilometers as my standard deviation. Now what I can do up here is I can just convert that probability. Instead of saying plus 10, I can subtract 10 from both sides, and I can say, hey, what's the probability that y minus x is less than 0? And it just makes the problem a little bit easier, because the only thing that's going to happen is I'm going to subtract 10 from both sides here. And so what I'm going to do is I'm going to have my distance, right? My distance is going to be normally distributed with a mean of 40, a standard deviation of 40, and now my problem is saying what's the probability that the distance is less than or equal to 0. So we'll go to Excel just to do something a little different and show you how that works there. Now to calculate the probability that we are less than a given number, I'm going to use Excel. So I'm going to come in here and I'm going to say equals norm dist, because we're talking about the normal distribution. The value that we're looking at is the probability that the distance is less than or equal to 0. So I'm going to put 0 in there. The mean of that distribution is 40. The standard deviation of that distribution is 40. And we always use a cumulative sum. And what this is going to do is it's going to tell us what is the probability, what is the area under that integral from negative infinity all the way up to 0 for a normal distribution with a mean of 40 and a standard deviation of 40. And we end up getting 0.15866 to 5 decimal points in this problem. Thanks.